Whoa. Space. Haven't seen this part of the bench in quite a while. Several months, actually. I know I said I was going to be working on the TV again, showing some alignment and stuff, but I'm afraid I've had to postpone that due to, let's just say, reasons. I've got some stuff coming in the mail that I want to work with on that later, and I will keep covering it, don't worry. I'm trying to actually finish the thing. It's missing parts, but I'm going to get it as done as I can. And it is playing rather respectably right now. However, today I want to look at something that I have featured previously, but I didn't really do a good job of. People certainly let me know that. I want to take another look at the 2-tube AM transmitter that I built while I was in college. This thing is entirely constructed using leftover parts from a junk radio that I had, and it was complete garbage. It was an AM/FM combo set thing that I used to hold my TV on, basically. But when I tore it apart, saved the power transformer as much as the good components that I could, including the tuning condenser and the oscillator coil, which these are fairly specially wound. I've tried using other inductors for this sort of work, and the waveform they produce is crap. RF engineers knew a lot more than I do about that sort of thing, obviously. But what I want to actually look at is how I built it. I do actually have a schematic now. I drew one up, and I actually want to show it functioning because I didn't do that either. I just kind of looked at it as a, I just looked at it. So to start with, when I was trying to figure out how to do this, I could start one from scratch and try doing that. I didn't know anything about AM transmitters, how they worked, how they were built. So the easiest thing to do is to look at what other people have done, try not to reinvent the wheel. Now, in the 1930s, a number of radio manufacturers like Zenith were actually making one-tube transmitters as part of record player attachments. So companies like RCA and others could sell a record player attachment, 78 RPM players that you could connect to one of their sets or a competitor set if you wanted to. A lot of RCA's and GE's sets came with a pair of terminals on the back, sometimes with a shorting plate, that would allow you to connect directly into the detector stage of the radio and use it as an audio amplifier for the record player, because the record player would just have like a crystal pickup inside the tone arm and a motor. There would be no amplifying electronics or anything inside. There was just, I've got two on the shelf actually I need to work on. And so you'd need an amp section to actually play the things. And you could either have a pair of connections made on the back of a unit, or you could use the ones provided, assuming that the company actually bothered to put them on there. When TV was becoming big, a lot of companies were putting terminals in the back for connecting a TV input or a phonograph input. However, in the 30s, the early 30s, TV wasn't, any more than the mechanical stuff we're working on. Anyway, some companies like Zenith actually started making wireless record player attachments, and the basic circuit they used had one tube for amplifying the audio input from the crystal, or usually a crystal pickup, early ones. Some of them were magnetic. And then another tube acting as an all-in-one oscillator and transmitting tube with a simple oscillator circuit that would broadcast on the AM band, so somewhere between 550 and 1600 kilocycles. It usually wound up being somewhere around 1,000. I want to say they were adjustable to some extent for the middle of the band with a trimmer capacitor. And the basic setup used a single, like a 688. Well, I shouldn't say that. I think more like a 117 N7. Usually a tube with a fairly high filament voltage so that they could be set up without a transformer. The point is, it was usually a tube that had multiple grids. You could use one grid as an oscillator section, and then another grid could be used to feed the audio input from the amplifier tube. And then that would be broadcast very short distance, usually a few feet. The idea was you would have it sitting on a table or directly on top of the radio you're trying to broadcast the signal to, and it would either blur out the station that it's transmitting closest to if the signal is weak enough, or you would tune it to a dead part of the band and then adjust the oscillator to match whatever frequency you want it to be. So obviously I wanted to do something similar, low tube count, and it needed to be adjustable. Obviously there was a lot of designs out there involving crystals, which would give you one fixed frequency, but the most common was 1000, because in a lot of other places 1000 isn't being used. Well, in the Pacific Northwest 1000 is very much being used by KOMO, so that was out. So I needed to make a variable frequency oscillator, or VFO. And I also needed the parts, the combination of capacitor and inductor, that would give me the standard AM band, and the easiest way to do that was to yank them out of an already existing radio. So I had that much figured out. The second part I needed to figure out was the oscillator section. And so I looked up what were the most common styles of oscillator used in a vacuum tube radio. The ones I'm most familiar with are the Hartley and the Colpitts oscillators, which are effectively the same circuit, except that they swapped the positions of the inductors and capacitors. Like literally, they just transposed them to form a different circuit. And so that wound up being me using a 6J5 triode, the most common one I could find because I wanted to use octals. 6J5 triode for that. And then on the actual output side, this was actually inspired by the kit that the Eclec-Tronics supply used to provide, which was a one-tube AM transmitter for old radios. They don't sell it anymore, which sucks because I wanted to buy one to play with. They don't even sell the power supply kit for battery sets that they used to, so that also sucks. Either way, their design revolved around using a 6A8, which was a very common octal mixer tube in the front end of pretty much every mid to late 30s radio, from 1935 on, of course, when they were introduced. Super common, and the 6A8 is great because it was purpose-built to be both the mixer tube and the local oscillator, if you wanted it to be. You could alternatively just have it mixing a separate local oscillator signal with the incoming RF signal to give you your intermediate frequency for the IF stages. In this case, or at least in Eclec-Tronics Supply's kit version, which they had based on the Zenith design with some tweaks, they were using this 6A8 tube with a small power transformer or filament supply, and they had a voltage doubler circuit to give them the high voltage and all that junk. But they set it up so that the grid cap here is your audio input. You have the oscillator grid hooked up with the tank circuit for the oscillator, and then that was all you had to do. Your control grid here is being used for the actual modulating signal, your audio input, and then the tube is effectively being used like the mixer it would be in a radio, except instead of producing an intermediate frequency by combining an RF signal it already has with a fixed sinusoidal signal, I'm just combining an audio signal with a standard sinusoidal output from the oscillator to produce an AM modulator, an amplitude modulated signal. Sorry if that was wordy. I didn't. Got a little hung up there. Anyway, the easiest way to show how I went about this, of course, is with this lovely drawing aid. Now, when I originally doodled this, I literally just Googled each of these circuits and I built them one for one with data with component values pulled from known circuits. So fairly good, and it had to be something I had on hand. If I didn't have it, it wasn't going to get used because I didn't have a lot of money to work with. So I'm trying to think. Let's see, what would be the best way to look at this? Well, okay, before I go to the schematic, we'll look at the overview of the thing. So from left to right, on the left here, we have my power supply. Hang on a second, I just left that plugged in, and I did write high voltage on there for a very good reason. My electrical engineering professor noted that if it's written in marker, it must be very serious, and it is. This, I should point out, the high voltage section of this set is directly connected to the line. There is no isolation, which means if for any reason I was to touch the inside of here, I could get a very nasty shock or electrocution. I did put a fuse on it though, very important. So the B plus is actually taken care of by a simple voltage doubler using a single 1N4007 diode. These two capacitors right here are bridged with a 2.2 kilo ohm resistor to kind of make a, it's not really a pi filter, it's mostly just there to provide a good rectified DC output, and that becomes our plate supply. I do have an X2 type capacitor across the supply leads. I just threw that in there because, I thought it might help. Again, I'm not an RF engineer. I have a bachelor's degree in electrical engineering. It's about as good as it gets. I did, however, want to make sure, because these are 6-volt tubes, I didn't want to have to go with a series hooked up filament string derived directly off the 120-volt power supply like a lot of AC/DC radios were. I don't want to have to take that up because I'd have to either use a capacitive dropper, some sort of complicated diode dropper, or a resistive element like a ballast tube. I didn't want to do any of that. I did, however, have a small 6.3-volt filament transformer kicking around in my scrap bin, so I pulled that out. However, the output voltage of this transformer on today's line voltage was closer to 7 volts, so I did have to add a dropper resistor that I calculated through trial and error, actually. Well, not total trial now, these are 300 milliamp tubes, so it was easy to figure that out with Ohm's law. So either way, this orange spiral wound wiring here is my filament supply for each of the tubes. The bright red wire connections are the B+. This shielded connection here is the output from the oscillator on the right to the mixer tube on the left. And then, of course, the black lines are all of the grounds. And the green connections up here are for the connections to the tuning capacitor. And a lot of this was very much trial and error. I actually used a decade capacitance box to figure out what a lot of these smaller capacitors roughly needed to be, and then I looked through my bin and looked to see if I had them. Other important thing that I needed, and that I just happened to have, was this guy. This is a radio frequency choke, the intention of which is to keep the modulated AM signal from showing up in the power supply. Because as this tube is doing its job, the current that it's drawing through the plate is constantly changing. Now, if I didn't have this choke in the plate circuit, that constantly changing current would be seen all the way back to the rectifier in its supply. Now, the capacitors can do a decent job of keeping up with that, but because both the 6J5 oscillator circuit and the 6A8 mixer circuit share the B+ connection, without this, the 6J5 plate circuit would start seeing fluctuations due to this tube drawing current, and that would screw with this one, and then the whole thing would probably not work very well at all. So this is acting as a blocker. So the 6A8 can do its job, the current through it can change, however, inductors actively act against rapid changes in current, because they put energy back into the system by drawing it out of the collapsing magnetic field, blah, 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 science, whatever. So there's that. Let's take a look at the actual schematic that I have beautifully drawn on some leftover notebook paper I had from college. So the power supply, again, there's a pointing device. Something, anything, screwdriver. There we go. Simple, AC input over on the left. I've got a toggle switch providing a power supply connection. A filament transformer here with a 2 ohm, I believe it's a 2 watt, either a 1 or a 2 watt metal film resistor there for the filament supply so that it keeps it right around 6.3. And then we have the, oh sorry, this is not a voltage doubler, I misspoke. This is just a half wave rectifier circuit using a single 1N4007. Two 33 microfarad 450 volt electrolytic capacitors that I had kicking around, and I did add a 1 mega ohm bleeder resistor across the last one so that the voltage drains off slowly after the thing's shut off, because otherwise once these tubes go cold there's nothing left in the circuit to drain them down, and I don't want to accidentally shock myself if I was working on it with it, unplugged. Then we're going to move down to the actual oscillator circuit here. Hang on. There we go. So our B+ connection comes down, and I had to fiddle with this circuit a number of times to get the output to where I was happy with it. And I was experimenting with whether I was using the B+ connection going through the short or okay. I have to preface that by saying the oscillator coil has a center tap and then it has two other taps on either side. One of them only goes about 2 ohms, the other is about 7.8 ohms. I experimented with using both the low side and the high side of it to see what would give me the best performance. Ultimately, going from the center tap with B+, and using the high side as the plate connection, and then using the low side here as the feedback connection to the grid worked the best. I checked it with an oscilloscope to see if the waveform was nicely sinusoidal and if the amplitude was decent enough. I wanted to get the maximum possible amplitude I could out of the circuit. I don't know whether that's best for a circuit like this, but that was just what I was experimenting with, as I'd never actually built anything previously with vacuum tube electronics. The coupling between the grid and the inductor here, the oscillator coil, I should say, I kind of fiddled around with the values. I have a 47 picofarad in parallel with a 22 picofarad capacitor to get the coupling that I wanted to make it work. Again, that was, I think I started off with the 47 and then I had to tweak it with 22 to be happy with it. Again, using a decade resistance box that had those values in there made it very easy. The tuning capacitor here is the one I pulled out, and it goes directly across the outer 2 terminals of the oscillator coil, so it sees the full load of that. The cathode on the 6J5 is just directly connected to ground, very easy. And then the output for this, I saw versions where the output was taken off the plate, and I saw versions where it was actually taken off the grid connection. I ultimately went with the one off the grid connection. And there is a 47 kilo ohm resistor here to bias the grid, a 47 picofarad coupling cap going to that shielded cable, and then another 47 kilo ohm resistor on the other side here that is shown close to the capacitor but is actually all the way up here on the 6A8, and that provides a little bit of bias to that grid. Now the 6A8 has some additional connections for suppressor grids. Those are just connected directly through a 100 kilo ohm resistor to B+. And then over here we have a 39 kilo ohm resistor hooked up to, again, there are additional grids in here that I don't fully understand the use for. It's to help with the extra capacitance that exists in multi-grid tubes to prevent oscillations from being set up accidentally. And there is also a coupling capacitor here, a 0.001 microfarad cap to ground. The audio input is stereo coupled through a pair of 100 kilo ohm resistors to get a roughly mono input, because again I can't broadcast in stereo. I would have to do side-by-side frequencies or something. I don't fully understand how they broadcast stereo. I haven't really looked into it. But the audio signal, the monaural audio signal comes in through the grid cap. Pretty simply, it's just an alligator clip with a piece of 22 gauge wire hooked up to it. And then the B plus supply for the 6A8 just comes directly through the radio frequency chuck, which is about 2.5 millihenries, goes into the grid through the plate, and then the actual antenna connection for this comes directly off the plate of the 6A8 through a 47 picofarad capacitor, which I think I just grabbed because I had a whole bunch of them laying around. All I know is that it does function well enough. I believe I have a digital version of this that I made in Express SCH. If I have that, I will put it up on the screen for you guys. However, I would like to actually show this thing in operation. First, though, I think we should see what the oscillator actually looks like on the oscilloscope. So I'm going to get this set up, and then I'll bring you over to the scope, and we can take a look at the output of that. Alright, we've got the BNK fired up, and we are connected directly to the oscillator grid of the 6A8. And what you're looking at is a honestly very nice looking sinusoidal signal. This is as small as I can seem to get it. I need to clean the wafer switches on the volts per division switch on this thing. They don't all seem to work very nicely. Now, I'm going to adjust the position of the tuning condenser, and I would like to note I don't have an insulated knob for this, so when I touch it, you are going to see the waveform crunch down just a little bit as it reacts to the natural capacitance of my body. However, if I open up the tuning capacitor, we can see our peaks and troughs getting squished together as the frequency increases. And overall, the result is rather nice looking. I don't get any clipping. I know you can't tell, but believe me, move that down right there. Not seeing any clipping at the top of the waveform, and we should... Oh, come on, behave now. Not seeing any real clipping at the bottom. You just have to take my word for it while this is misbehaving. Oh, come on. Whatever. Either way, that's how it looks. Now, this tuning capacitor has two sections to it because this was an AM/FM radio. So I don't remember whether I'm using the AM and FM sections or if I also borrowed one from the local oscillator. I should just be using the one for the AM local oscillator. That one, yeah, that one I think is for the FM LO. Much higher frequency. I just threw that in there because I thought it would be interesting to see what it would do. So I've actually got a selector switch to move between those two different sections of plates, but they both share a common ground connection through the chassis. Either way, that's what the LO looks, or the oscillator section looks like. I was very happy with that. Stop it. Thank you. So that works well and good. Good connection on everything. Now all we need to do is grab an audio source. And I will also show what the resulting waveform looks like on the output of the tube. So right now we are connected off of the end of the antenna connection through my probe, and we're grounded to the unit, and it is through an isolation transformer for safety reasons. This is the waveform as it's coming directly out of the oscillator here. Let me see if I can adjust this. You can also see that as the frequency changes, the amplitude of the output does as well. A little annoying. So I'm keeping it at the low end of things so that this is a little easier to see. What's going to be a bit difficult to see is the modulated signal, because it turns out the percent modulation on this thing is embarrassingly low, which would explain why the few times I used it, it didn't sound all that good. So I'm going to run a 1000 Hertz test tone from my iPhone through the audio input, and we could just barely see what that looks like. So let me crank up the intensity here and adjust the focus so it's sharp enough. It may not be easy to see, so let me try moving the camera in a little closer. And I'm going to look at one of the peaks here. And I'm going to pause the signal. So you can see how the top of the waveform stops freaking out. And there we go again. That little blip of activity there, that is the audio signal riding on the carrier. Not much, I'll tell you what. But it is technically working. So now the only thing left to do is to find a radio that works. I'm sure I've got something around here that I made work, right? I'll be right back. I've got my supply hooked up and the radio is on and playing.
Apparently you can't fix leaks either. Tired of leaks or low water pressure?
Now I've only got a short antenna hooked up to it, and the
they can repipe your whole house with new PEX tubing.
let's see here.
Guarantee no leaks for life. Call 800.
There is a bit of interference. I got a lot of electrical stuff going on. The LED bar lights that I'm using are actually not providing as much interference as the fluorescents that are still in the wall. Those things produce an awful lot of damn noise for this. However, what's cool is we can actually tell this is working if I just spin through.
And over the past 2 years, many
of us have
postponed medical and dental overall health and prolonged dental
I can, from here anyway, I can see the eye tube closing. I'm producing a relatively strong enough signal.
Pediatric dental care for your child. Just be sure to consider Dr.
trying to make
Julia
a video.
Richmond at Dino Kids Dentistry, where your child's health, safety, and well-being is priority one. Dr. Richmond's extensive experience in pediatric dentistry range from children of all ages.
So if I fire up this test tone, and I've got this thing cranked to maximum output, and I interrupt this broadcast.
Of her state-of-the-art practice, start making dental visits a pleasant experience for your child. Set your child up
Yeah, not a great noise.
Online at dinokidsdentistry.com.
So let's switch to somewhere that doesn't have a lot of activity, which realistically is going to be toward the lower end of the band.
Thank you. Important point.
Okay, right about there, doesn't seem to be much of anything. So let's try that. This might be easier. Alright, so that's about as close as I can get. So you can see when I press pause, there's our signal. Unfortunately, there's a god-awful amount of noise. That's slightly less. I think part of it is the fact that I'm using this isolation transformer, maybe picking up that noise as well. Alright, so I'm going to do what any smart person would do. I'm just going to relay the antenna from the transmitter over the antenna from the radio to get rid of as much of the noise as I possibly can. Ow, God. Okay, so yes, it works. In very close proximity. But what does it sound like if we're dealing with music? Honestly, not bad, but I imagine if I didn't have the antenna from this laying over the antenna of that, I probably wouldn't get a very good signal. Again, a lot of these little transmitters were meant to be like sitting behind the radio, especially the kit builds, or sitting on top of the thing. Because in a lot of cases, they didn't really have a proper antenna. The radio frequency choke was actually doing the job of being the antenna. Because you got a giant coil of wire right there that is pulsing with RF energy from the plate circuit of the tube, so it's sort of doing it for you. I've seen some designs where they use a Quaker Oats can to wind the magnet wire around to form the RF choke, and that becomes your antenna. But, audio quality isn't bad, it's muddled, but again, this is an AM transmitter, and again, it's made out of junk. Well, what about human speech? How does that sound? Oh, that's a hard pass. Hang on a second. I'm not saying all the music from that generation was great.
So a voice within me keeps repeating, you, night and day, you are the one. Only you.
Just to prove that I'm not just injecting the audio directly.
It's no matter, darling, where you are, I think of you.
Okay, but suppose it didn't have this antenna. I'm assuming the radio itself would have an antenna hooked up. I've got about 2 feet coming out of the back end of this thing. What happens if this doesn't have an antenna? Let's see what we're looking at in terms of audio quality. Well, it's there. Now suppose I add the antenna length that I had on the transmitter to this. Alright, so that didn't necessarily make things better. So without the antenna extension on the radio, and when just having an antenna extension on the transmitter, pardon my intrusion.
There's an old thought, a hungry yearning burning inside of me.
It's not bad.
And it's coming slowly through.
But I think that about does it for this. Point is, yeah, you can make one of these yourself with junk parts. If I was to do it over again, I would absolutely, for one thing, I would add a proper power supply with an isolated B+ section. I would probably use a transformer that already has a secondary for the filament winding, a secondary for the B+, and so on. I would not be using a tuning capacitor like this. I'd try to find a simpler one. If you got a junk All-American 5, a lot of people like to use the parts out of that. And I would definitely add a proper section of audio amplification, and I would make sure that it is at least somewhat what's the word I'm looking for? Impedance matched. Because I am not doing the least bit of impedance matching. There's nothing. This grid cap is directly connected to the audio source. I kind of have an extra resistor thrown onto ground to give it a little bit of bias. We're talking about a few, I don't know, if even a few volts of audio signal coming out of the phone. I've never measured it. Can't imagine it's much. So it's not a super strong signal, but if you've got something simple like this sitting behind the set with a few inches or even 6 inches of antenna, it would probably sound pretty good. As a set for trying to broadcast through a house, no, it's going to be terrible. I will say that the reception on this could probably be greatly improved, assuming I was using an antenna of the length specified by manufacturers at the time period, which was usually an external wire of about 100 feet, I think is what a lot of people recommended. And also a good ground can do wonders for eliminating interference. And although it has a ground stub, I don't have a good ground connection in this room to use it. Well, actually no, I take that back. The conduit in the room here could actually serve as a pretty decent ground because it is grounded to cold water pipes elsewhere. But good ground, good antenna for this would help, and of course the design of this could be vastly improved by adding better audio amplification and coupling, better power supply, and yeah, just better parts all around. There are much better designs out on the internet than what I've done. But that does it all. That does it for this video, I think. Thanks for keeping up with my blathering. And hopefully next time we'll actually see moving pictures.